In this video, we will motivate dynamic programming using the Fibonacci sequence. What is a Fibonacci sequence? Let's suppose we start with a couple of ones. We're going to take the next value in the sequence to be the sum of the previous two. And the next entry is the sum of the previous two. So 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 21, and so on. And we can assign indices to those. Okay, so the seventh entry in the Fibonacci sequence is 21. We want to write a function to compute these values. So let's just say we have some function called fib. And we'll find the 0th entry and or this 0th term. Now let's go ahead and write that function. So we come to our Fibonacci.h. We're going to write a function called fib, pass in the index of the term. If the index is 0 or the index is 1, so this is the base case, we'll return a 1. So that gives us these first two ones. Otherwise, we're going to make a recursive call, n minus 1 plus Fibonacci n minus 2. Okay, let's see if it works. So we're looking for the 0th term, and look, it returned a 1, which is the 0th term, right there. Okay, let's try the first term. Okay, how about the 3rd? And the 7th. 21. Good. And that matches right there. Let's try the 15th term. Okay, how about the 25th? So it's getting pretty big, pretty fast. Kind of makes sense. Let's try the 45th term. So we're waiting. How many recursive calls are we making here? Seems like we'd make 45, I don't know, maybe 90, something like that. But it's taking an awfully long time to compute the 45th term of the Fibonacci sequence. And there we got it. There's the value, whatever that is. So what's going on here? Why did it take so long? To investigate, let's create a variable called call count. And we're going to find out how many times the function fib is called. Okay, so here's our fib function. Now notice that I passed in call count with an ampersand after the type. That means I'm passing it in by reference. Now, pass by reference, if I make a modification in the function, it is reflected here in the original value. So what this is going to do is increment that single value call count every time the fib function is called. Now we need to pass in call count to the recursive calls. And let's run. I didn't want to run for 45. Let's run for 5. And we also want to print out call count. Okay, so to calculate the 8th term of the Fibonacci sequence, we made 15 recursive calls. Well, 14 recursive calls. We had the one original call. Okay, how about 25? And 242,000 calls to fib to compute the 25th term of the Fibonacci sequence. And how about 45, that one that just killed us on time? Let's see how many calls into fib it's making. And there we go. Call count, it's more than 2 billion. It exceeded the largest number that an integer can store. So what we're looking at here is a problem where we have a tremendous number of subproblems and they're overlapping, and we need something to fix that, and we are going to use dynamic programming.